In this assignment, you're going to look for associations between interval level variables using scatterplots, regression lines, and correlations. If you recall in the past, we did a lot of work looking at associations between ordinal and nominal level variables using scatterplots and chi-square statistics. Here we're going to look at association between interval level variables using some different methods that this assignment is intended to introduce and help you understand. And if you recall from the very beginning of the semester, when we started to talk about nominal, ordinal, interval level variables, I said, well, why are we learning these concepts? What's the point of this? The point is that the type of technique you use to analyze the variables often depends on what level the variables are at. So if they're nominal level variables, then when you're looking for associations, you're going to use a crosstab probably. If there are two interval level variables, you might use scatterplots, regression lines, and correlations, as we do here. Now, in most cases in this class, I've used actual real data because I think that's more interesting than some of the fake data sets you find in a lot of stat books. But in this case, I think it's useful to look at just a canned fake data set that I have right here, where I have a set of 4 students, and I'm listing out their lifestyle, the number of beers that they drink in a week, and their GPA. And if we just look at this data before actually getting into the meat of this assignment, we can see that, and we can just guess from our own observations, that the more party animal type people probably have lower GPAs than the more studious people. So you can see that here. If we look for the person who is all about play, which is Carl, drinks 12 beers a week, and his GPA is below 2, which is the threshold for being on academic probation at William Patterson. Then you take someone like Georgina, sort of the opposite. She's all work, little play, and she has much higher GPA, 3.5. So it seems like GPA is related to number of beers you drink, which is sort of an indication of how much somebody is a party animal versus how studious they are. But the idea here is we want to get a general sense of this, okay? And if we go back and just think about what is an association between variables, well, when you have 2 variables, beers and GPA, those variables are associated if one tends to go along with the other. So for example, in this case, beers probably tend to go along with GPA in that as beers go up, GPA tends to go down. Okay? If as the number of beers go up, GPA didn't change, we would say there's no association between beer and GPA. If as the number of beers goes up, GPA went up, not only would be people drinking themselves silly, but we would also say there's an association. Okay. So the first thing we want to do is to copy this data set into Excel. And it's already in table format, so this should be pretty easy to do by copying and pasting. And should be able to paste it. Try to paste it as HTML. You can paste it in a variety of ways, and there it is. The name, the lifestyle, number of beers, and the GPA. Now, the first thing we're going to try to do is create a scatter plot. And in a scatter plot, you have, it's a 2-dimensional thing. You have in the x-axis, you have what's called the independent or causal variable, the cause. In this case, that's going to be beer. In the y-axis, you're going to have the dependent variable, or the effect variable. In that case, this is GPA. Now, if the variables are aligned correctly with the x variable on the left and the y variable on the right, then it's really convenient, and we can just highlight those two variables like that. Go to Insert, choose Scatterplot, choose the simplest scatter plot there is, and we end up with sort of rudimentary scatter plot like that. In many cases, though, your x and y variables are not going to be right next to each other like this, and you're going to have to just play around with it using the select data feature. But in this case, for this simple example, I'm putting it in a straightforward way here. So this is a very rudimentary chart, and we want to change it to make a little bit more sense here. First, I'm going to change the chart layout by looking at one of these templates here. I'm going to click on layout number 1. It adds these axis titles. Now remember what I said about the x and y axis. We have on the x-axis number of beers, and I'm going to indicate that by changing this axis title here, going in like that, number of beers per week, something like that. And as you can see, it ranges from 0 to 12. And in the y-axis, I can click on that and highlight it. This is going to be student's GPA, like that. Okay, and then we can label this title GPA by number of beers per week. We can get rid of the legend. We should get rid of the legend because it's only meaningful if you have multiple groups, which we don't have. So looking at this doesn't really mean much until you really understand what's going on here. Each of these diamonds represents a different person. Unfortunately, there's no simple way in Excel to label these. It'd be nice, but there's none way to do that. So it's useful, though, just an exercise to make sure you know what each of these are. So for example, this diamond here represents someone who drinks not at all. There's only one person who doesn't drink at all, and that's Derek. Here is 0, and he's a 3.8 GPA. So this diamond right there represents Derek. Okay. And if we go down the line, if we go at the other end, this diamond here, the person who drinks 12 and has a GPA just below 2, that represents Carl. Okay. Now, when you're thinking about a scatter plot, before we go farther, the idea is that if there's an association between two variables, okay, then, or I should say, the more that there is an association between the two variables, the more that these dots will cluster along in some sort of line-like formation, either going this direction down, indicating a negative relationship, or if there's a positive relationship, diamonds might be lined up as if there's a line amidst them going the other direction. So, and then put this in a more straightforward way. If there's a negative relationship, as we would expect, between number of beers and GPA, what this means is as beers go up, GPA goes down. Then the people with the high GPA should have a low number of beers per week, or vice versa. People with a low number of beers should have a high GPA. People with high number of beers should have a low GPA. So we should see the diamonds cluster over here and over here. Okay? If somehow, in some freak way, beer caused people to earn better grades, we have the opposite, and we'd have diamonds in this corner representing the people who are drinking very little at a low GPA, and the diamonds, and then we'd have a diamonds over here, clustered over here, indicating people who drank a lot and had a high GPA. Now, in the real world, especially sociology kind of data that sociologists are used to looking at, things are not really clear and crystal clear. The relationships between variables tend to be somewhat weak because there's a lot of things going on. There's a lot of things that affect GPA. Some people might be able to party hard and do well in school. So there's exceptions, and so for every exception you would have something that's not following this pattern, and then that'll affect what we get a little bit later when we talk about regressions and correlations. So we have the scatter plot here, and really here we're looking to see if there's any sort of pattern among these dots. It doesn't have to necessarily be a pattern whereas one goes up, the other goes down. You could have a situation, for example, where maybe people who drink a little bit aren't really doing any worse in school than people who drink not at all. But once you get up to a very high amount, then suddenly the grades drop. So it really doesn't have to be linear or very simple relationship. It could be more complicated. There could be some threshold where if you drink below a certain threshold, you're just fine. There's no difference in your GPA. But then above a certain threshold, you're just completely sloshed, and the GPA goes down the toilet. That's what you can kind of see in a scatter plot. We only have 8 points here, but if we had more points, we might be able to see those kinds of patterns if they did show up, just by looking at where the dots are on the line and what kind of pattern they might demonstrate. But of course, the more exceptions there are, the less, the harder it is to find a pattern. And scatter plots can be somewhat hard to interpret, which is why sometimes then we also add a regression line. And a regression line is a summary of this relationship. In other words, regression line is where we draw a line that sort of summarizes the general relationship between the number of beers per week and the GPA. And we do this in part because then regression line allows us to predict, okay, given a certain amount of beer consumption, how much, what somebody's GPA might be predicted to be. So to add the regression line, I go to Layout within Chart Tools. If I come out here, Chart Tools is going to disappear. So I need to click on the chart. I have Chart Tools like that, Layout, Trend Line, and then I want to choose a linear trend line. But because I also want the regression equation itself, I'm going to go to More Trend Line Options. And it's already picked a linear trend line, so that's what I want. And I also want to display the equation on the chart, like that. And now it leaves me like this. I'm going to move this chart to a new sheet to make it larger. And so here, now we have a chart with a little bit difficult to see because some of these numbers are small. But we have the regression line, and I need to talk about what does this mean. Now, regression line, this is y equals negative 0.0787x plus 3.3559. This regression line is in the same format that you probably are all familiar with from middle school, the y equals mx plus b, which is the general form for a line. The y equals mx plus b, m is the slope, and in this case m is equal to negative 0.0787. Now what does that mean? Well, what it means is it's a prediction. X, remember, is what's in the x-axis. That's the number of beers. Y is GPA. So with this y equals mx plus b, we can actually predict, based on the number of beers people drink, what their GPA is going to be. In this case, you can say for each additional beer drank per week, the GPA is going to go down by 0.0787. That's the prediction. So the y equals mx plus b, that equation from middle school or wherever you learned it, is not just some abstract thing. It's actually kind of useful in certain contexts to predict things. You can do the same thing if you have some data on education income. You can have a regression equation predicting, okay, based on the number of years of schooling somebody has, what's their income predicted to be. So that's the M. Then the other number here, the 3.3559, that's the B in the y equals mx plus b. B is the y-intercept. And the y-intercept is simply what we would predict y, in this case GPA, to be if x was 0. So in other words, if a person drank nothing per week, what would we predict their GPA to be? And we predict their GPA to be 3.3559. So that's a general sense of what that regression line means. The y again being GPA and the x being number of beers, and we say that the x is the independent variable or the cause variable, and the y is the dependent or the effect variable. Now, if we have this prediction, right? We know, okay, not surprisingly, there's a negative relationship. More beer, lower grades. But the slope doesn't really tell us how strong the relationship is. Okay, it tells us a little bit about that, but if we want a single number that gives us a sense of strength. So for example, let's say we wanted to know whether the effect of beers on grades was larger or smaller than, say, the effect of working, right? So the question is, if somebody's partying hard, does that have a big effect on their GPA relative to, say, if they're working hard on a paid job outside of school? To get a sort of more generic or standardized measure of the strength of association between variables, we need what's called a correlation. And there was a reading about this that should help you understand what a correlation is. But a correlation is a number that ranges between -1 and +1. And you can take two things from a correlation: the direction, which is whether it's negative or positive. In this case, it would be negative, indicating that as beer goes up, GPA goes down. And there's also the magnitude of the correlation, the strength of it. Larger correlations are correlations that are farther from 0. They might be negative or positive, but farther from 0, closer to either -1 or +1. The weaker the correlation, the more it's closer to 0, either negative or positive. Now, to get a correlation between beers and GPA, we can use the function in Excel, the correl function. And I can just type in anywhere here the equal sign, correl function, like that. And then in parentheses, note that it's asking for what it calls an array, which is just a set of numbers. It's basically asking you for both variables. It doesn't really matter the order you put them in. And you can just highlight them. So I'm going to highlight the beers variable. And then it enters the address automatically for me, in this case C2. And this colon means it's like a dash, C9, comma. Then I highlight GPA. It gives me the address, like that, D2 to D9. Close parentheses, like that. And then I press enter. And now it gives me this correlation. Now that number doesn't mean anything until you really interpret it and provide some interpretation. First of all, it's negative, which we already knew that, because as beers go up, GPA goes down. But the other thing is the size of it. Remember, correlations range between -1 and +1. And the farther the correlation is from 0, the larger it is. In the reading on correlations, I talk about what we consider just the rules of thumb for how large the correlation needs to be considered strong, moderate, or the weak. In this case, this would be a moderate negative correlation. Now, what does it mean to have a strong or a weak correlation? Well, the stronger the correlation, the fewer exceptions there are. The weaker the correlation, the more exceptions there are. So if we were going to correlate, say, the length of someone's left leg with the length of their right leg, since very few people have legs of different lengths, correlation between those lengths would probably be close to 1. Very few exceptions. People who have longer right leg have longer left leg. But in this case, in the beer's GPA case, there are people who party hard but also do well in school, or they drink a little bit more than average but they also do well in school. So, and that's what this correlation tells you. It's not, if the correlation were, say, negative 0.8, 0.9, negative 0.9, then we'd say basically it's just GPA is just totally determined by the number of beers you drink. It's just totally driven by that, or something related to that that's really driving it. But here we see that it's relatively strong, but and there's certainly a relationship. It's not nothing, but there's also a lot of exceptions.